Hello students, I received many questions asking me if I could redo the questions 16, 17, 18 from section 7.1. So here is a video that explains a little bit better how to solve these questions. The first question says the blades of a wind turbine are 116 feet long and the propeller rotates at 15 revolutions per minute. First of all, what do we have? We have the speed. That is the angular speed. How did I know? Because it's measured in revolutions per minute. We want to find the angular speed of the propeller in radians per minute. So here is a fact. It's easier to convert revolutions to radians than convert miles into radians. So if you want to convert miles or inches or feet, you have first to do some conversions here to turn it into revolutions, and then from revolutions you're going to turn it into radians. We already have the speed in revolutions per minute, so we have 15 revolutions per minute. Now the question is, how do I convert revolutions into radians? So I'm going to ask myself, how many radians are in one revolution? And the answer is very simple. One revolution is going to have 2 pi radians, always. 2 pi radians, always. So I'm just going to say here, I need to remove the revolution, so I have to write the revolutions into the denominator. So one revolution is equal to 2 pi radians. Remember that radians is not actually a measure, so it's okay to write your answer as 30 pi per minute, or you could say radians per minute. Okay, so that is the angular speed, which is omega. Now, we want to find the second part is asking about the linear speed. We know that we have the angular speed. What else do we have? We have the radius of the circle that the propellers are making. Because if you just make an imaginary circle here, then this is basically going to be the radius. The radius is 116 feet. So we have R equals to 116 feet. And we have omega is equal to 30 pi radians per minute. So we know that the linear speed or the linear velocity is equal to R times omega, which is equal to 116 feet times 30 pi radians per minute. Remember, radians is not a measure, so the final answer is going to be, let me do the math really quick. It'll be approximately, since we're approximating pi by 3.1415, so it's not the exact pi, the answer is going to be 10,932.42. The measure is going to be feet times radians is feet per minute. So you see here, this is a linear speed because the measure is in feet per minute. It could be in feet per second, could be inches per second, could be miles per second, miles per minute, miles per hour, meters per minute, meters per hour, kilometers per hour, something like that. So that is the difference between the angular speed and the linear speed and how you can tell the difference between them. The second part, or number 17. Number 17, you have a car that is moving at a rate of 28 miles per hour. That is basically a speed or linear speed. So I'm going to say this is V. And the diameter of its wheel is about 2 1/3 of a foot. I see like there is a fraction here, and I know that feet can be converted into inches. So I'm just going to convert this into inches. This is the diameter. So the diameter is going to be equal to 2 feet is equal to 24 inches because 1 foot is 12 inches. And then 1/3 of a foot is basically 12 divided by 3, which is 4. So 24 plus 4 is 28 inches. what do we want to find? We want to find the number of revolutions per minute. We know we can convert miles, which is we have here, into revolutions. But because the diameter is measured in inches, I know that I have to convert into feet first and then inches, and then I'm going to convert to revolutions. So that's what I'm going to do here. What do I have? I have 28 miles per hour, and I need to convert the miles into inches and the hours into minutes. So that's what I'm going to do. First, I'm going to convert the miles. 1 mile has 5,280 feet, and then I need to convert that into inches just because I changed the measure of the wheel or the diameter of the wheel into inches. So 1 foot is 12 inches. Next, I'm going to convert the hours. So I know that 1 hour, notice how if I want to get rid of something, I write the same measurement in the opposite place. So if the measure is in the denominator, I write the other measure in the numerator so they can cancel each other. And 1 hour is 60 minutes. I'm going to stop right there because I reached my minutes. Now, the miles are going to cancel with the miles, and the feet will cancel with the feet, and the hour is going to cancel with the hour. And then the final answer will be 28 times 5,280 times 12 inches divided by 60 minutes. What do I have left? I have inches per minute. That is my units. Okay, I'm not there yet. I still have inches that I need to convert into revolutions. First, let me find the final answer for this multiplication and division. So I found the answer to be 28,568 inches per minute. Now I need to convert these inches into revolution. So I have to ask myself, in 1 revolution of the wheel that has a diameter of 28 inches, how many inches are there? The answer is exactly the circumference of the wheel, or the perimeter of the wheel. And the formula for that is going to be 1 revolution. Let me write it over here. So in 1 revolution, I have how many inches? Because I asked inches, that's exactly 1 revolution of the wheel, or the circumference of the wheel, or the perimeter of the wheel. So because this is a circle, it's the diameter times pi, so it's going to be 28 pi inches. This is the key here. Okay, that means in 1 revolution, the inches has to go in the denominator, so 28 pi inches in 1 revolution. What's going to happen is the inches are going to cancel with inches, and then you divide this number by 28 pi, divided by 28, divided by 3.1415. The answer is 336.15 revolutions per minute. Now that we have this in revolutions per minute, the second part is going to be easy because we just want to find the angular speed in terms of radians per minute. We know that converting from miles to radians can't happen right away. It's easier to convert to revolutions in the middle, and then we convert to radians, and we already did this part. So what do we have? We have 336.15 revolutions per minute, and we want to convert that into radians. So we need to remove the revolutions. In other words, I'm going to ask myself, how many radians are in 1 revolution? The answer is just 1. In 1 revolution, we have 2 pi radians. You see the difference between this formula and this formula? In the first formula, I have inches that I need to convert to revolutions. In the second formula, I have revolutions that I want to convert to radians. So if you have something given in miles per hour, you're always going to use this formula first to convert it into revolutions per minute or revolutions per second. And then you're going to use the second formula to convert it to radians per minute or radians per seconds. So I need to get rid of the revolution. It has to go in the denominator. In one revolution, we have 2 pi radians. So that converting depends entirely on what you need to end up with. We need radians per minute. That's why the question was, how many radians are in one revolution? And this is always the case. In one revolution, we have 2 pi radians. If you want to convert inches, it's going to depend on the diameter or the radius of the wheel or the circle you're working with, which is basically one revolution is the circumference of that object. Now, these will cancel together, and you're going to multiply with 2 pi. So you're going to multiply with 2 and 3.1415. The answer will be 2,111.99 approximately, or you could say it's approximately 2,112. The measure is radians per minute. I hope this is clear. Now for number 18. For number 18, it says the edge of the Ferris wheel turns at an angular velocity of 12.5 radians per minute. What is the angular velocity at a point of 10 feet from the center? So the angular velocity doesn't change whether you measure it in the middle of the radius or at the edge of the radius. So this distance or the radius doesn't really matter. So I'm going to say the angular speed is going to be the same, or the angular velocity is going to be the same, because the angular velocity is the change in the central angle with respect to time. So I'm going to say the angular speed is the same at the edge or close to the center. So omega is equal to 12.5 radians per minute. It's the same speed. It's the same speed anywhere on the wheel, here or here or here or here or anywhere. It's exactly the same. If the question wanted you to change the angular speed to a linear speed, then we can use the radius. We can use the radius 10 feet, which is going to be basically v is equal to, which is the linear speed, is equal to r times omega. And then you use this formula and find the answer, only if the question is asking about the linear speed. The last one. A truck with 28-inch diameter wheels is traveling 55 miles per hour. We want to find the angular velocity. So we have a linear velocity here. I know because it's measured in miles per hour. Angular velocity is either measured in radians per seconds or in revolutions per seconds or minutes, or but it has to be radians or revolutions. So we want to find the angular speed of the wheel in radians per seconds. Just like I said before, I have miles in this case. To convert them into radians, I need first to convert them into revolutions. And it's not hard to convert from miles to revolutions, but it's going to be difficult to convert from miles to radians right away. So I'm going to do the second part first, which is this part, and then I will do the first part, which is finding the angular velocity in radians per second. What do I have? I have 55 miles per hour, and I want to convert them into first revolutions per minute. So I know that I have to convert my miles into into inches in this case because the wheel is measured in inches, or the diameter of the wheel is measured in inches. So my miles have to convert into inches and my time has to be converted into minutes. So I'm going to convert the miles first. I have 1 mile is 5,280 feet and 1 foot is equal to 12 inches. Then I'm going to convert the hour. I know that 1 hour is 60 minutes. Then I'm going to do the math really quickly here. So this is what I have. Of course, the hours will be cancelled. The feet will be cancelled and the miles are going to be cancelled. And I'm going to end up with 58,080 inches per minute. So now I have inches per minute. So here I have to convert to feet and then inches and then revolutions. So the question here is, how can I remove the inches and switch them to revolutions? So the essential question will be, in 1 revolution, how many inches do you have? Because I asked how many inches, I know that 1 revolution of the wheel is basically the circumference of the wheel or the perimeter of the wheel. And that is the diameter times pi. So diameter times pi is 28 pi inches. So here I can multiply. I can say I need to remove the inches, so the inches has to go in the denominator. So 28 pi inches are in 1 revolution. And then inches is going to cancel with inches. And you will have this number divided by 28 divided by 3.1415, which is pi, and that is going to give me a final answer of 660.29 revolutions per minute. Now this is the second part I answered. The first part is find the angular velocity in radians per second. Now it's easy to convert from revolutions to radians. And it's easier to convert minutes into seconds. So all I need to do is 660.29 revolutions per minute times. Now I need to convert the revolutions into radians. So the question is, how many radians are in 1 revolution? I know in 1 revolution there are 2 pi radians. So I'm going to say in 1 revolution, 2 pi radians. And that means I have to multiply this number. Let me just write it again, 660.29 times 2 times 3.1415, which is pi, equals this number, and then I have to divide by 60 because I want to convert to seconds. So here I forgot that 1 minute is equal to 60 seconds. And the final answer, after you do the math, you're going to get 69.14 radians per second. And this is the other part of the question. I hope this helped you. If you need any help with these types of questions, please let me know.